So we have notes. Okay, so there are a couple of things that we need to talk about first, just to refresh our memories. We need to remember that GCF stands for greatest common factor. Meaning, what can everything be divided by? So we're looking to see in this polynomial, in this multi-termed problem, what can all pieces, what's the largest number that they share that they can be divided by? So the first thing that we need to be aware of is that the polynomial must be in standard form. If it's not in standard form, you need to fix it. The polynomial must be in standard form. And again, we are now going backward. We're going to have a polynomial, and we're going to factor it. We're going to make the original problem. Up until this point in math, we've been distributing. We just learned to FOIL, right? We've been taking out the parentheses. We've been combining things. We're now working backwards. We're going to have the answer, and we're going to go backwards to create the problem, quote unquote. Once it's in standard form, or if it's already in standard form, you want to find the GCF, greatest common factor, what can everything be divided by, for all the terms. It's not what can the leading coefficient be divided by. It's what can everything be divided by. What does everything have in common? This is what we're looking for. We are looking at the coefficients and the variables, because this is algebraic. We have to say the greatest common factor, because we are doing an algebraic sequence, an algebraic polynomial, it has variables in it. We not only look at the numbers, coefficients, but we look to see what variables do they share. Maybe they share multiple variables. Once we do that, we're going to divide each term by the GCF. This is the undistributing. Undistributing. Instead of taking the number outside and multiplying it inside, we've got a problem, and we're going to divide everything and put that number outside. We're undistributing it. Now let's also do a little bit of review. Hopefully this is not mind-blowing. When you divide, please remember, you divide the coefficients and you subtract the exponents. And then we're going to write our answer. We're going to write the problem, because it's going to look like every problem we've had up until now. When you're given something with parentheses, our initial thought is to distribute, right? Get rid of the parentheses. However, today we're given the answer and we're undistributing it. We're making the problem. The GCF goes outside the parentheses. Parentthesis. The quotient, the answer to a division problem, stays inside the parentheses. We're going to practice. Are you ready?
No.
Too bad. All right. 3x to the third plus 12x squared plus 9x. Now, hopefully you don't need your factor squares for this. But if you do need your factor squares to look to see what can 3, what can 12, and what can 9, what's the largest number that all 3 can be divided by, right? So this is what this is going to look like. Are you ready? 3x to the third is really 3xxx, correct?
Yeah.
That's the prime factorization of that term.
What?
3 is prime, can't be divided by anything.
Yeah.
And x to the third is really xxx. However, 12 can be factored. Do you agree? I can factor it to become 3 and 4. 3 is prime. And 4 can be factored to 2 and 2. So the prime factorization of 12x squared is really 2 times 2 times 3 times x times x. And then 9x, 9 becomes 3 times 3, right?
Wait, why is there... Oh, never mind.
So 9x is 3 times 3 times x. Is this all true? Now, you don't have to do this every time. I'm just showing you one way of looking at it. What do they all share? They all share a 3. Do you agree with that? And they all share an x. So what is the greatest common factor of all of these? 3x. If I write it out this way in the beginning, I can also look to see what's left behind. What's left behind here is x squared. Do you agree? What's left behind here? Plus 4x. And what's left behind here? That's my quotient, the answer, what the leftovers. And the GCF is going to go in front. And that's the undistributed version of this, which is the same thing. I got the same solution. If my greatest common factor is 3x, 3x to the third divided by 3x. 3 divided by 3 is 1. And x to the third divided by x is x squared. 12 divided by 3 is 4. And x squared divided by x is x. 9x divided by 3x. 9 divided by 3 is 3. And x divided by x cancels out. So there's my solution. We're going to practice.
If 9x, if it was 9x squared, would the greatest common factor be
X squared.
Because
You're looking for the most things that they share.
It's chilly.
Okay. Practice. Make sure you can flip back and forth to that factor square if you need it. All right, so let's start off number 1. 36f plus 18f squared minus 3. What should I do first?
Well, you have to find the greatest common factor of 36 and 18.
I would need to, but what do I do even before that?
What?
Put it standard form.
Put it in standard form.
That doesn't. No, it's not.
18f squared plus 36f minus 3, correct?
yes.
Now, Lance is right. My second step said greatest common factor. So I'm going to ask myself, what can 18f squared, 36f, and negative 3 all be divided by? What's the largest number? 3 can be divided by 18? 3. Can they all be divided by a variable?
No.
No, because there's a variable here, but the third term does not have a variable. So they can only be divided by 3. Now let's divide everything. 18f squared divided by 3,
6.
f squared, right? 36f divided by 3 is
6F.
12.
What?
Yes.
positive 12f. And negative 3 divided by 3 is negative 1. That's the leftovers, and I have to always remember, put your greatest common factor in front. I just undistributed it.
Oh, I see.
All right, let's try this guy.
Let's see how this works now.
Negative 42x to the 5th plus 96x to the 4th minus 22x. Now, this has an extra trick. But before we go there, let's talk GCF. What can negative 42, 96, and negative 22 all be divided by? Anything else? Anything bigger?
6.
12.
You're just guessing. Look at 42. Look at 96.
2.
And look at 22. The largest number they can all be divided by is 2, which is kind of crazy. I get it. Can they be divided by anything else?
Yes. X.
They all also share 1x, at least. So the greatest common factor is 2x. Now I'm going to throw a whole curveball. And here's what it is. If the leading coefficient is negative, doesn't matter about anything else. If the leading coefficient is negative, the GCF is negative. If your GCF, or no, if your leading coefficient is negative, your GCF also needs to be negative. So in number 2, is my GCF negative? Because my leading coefficient is negative 42. So I need to factor out that negative. So let's find our answer. What's negative 42x to the 5th divided by negative 2x?
Negative 20.
Positive
Positive
21, what? X to the 4th. Because negative 42 divided by negative 2 is positive 21. X to the 5th divided by x is x to the 4th. You divide your coefficients, subtract your exponents.
Yes.
96 divided by negative 2, negative 48. X to the 4th divided by x is x to the 3rd. And negative 22x divided by negative 2x is positive 11. And then put your greatest common factor in front.
What did you get? Did anyone answer?
We're still taking notes. Number 3. All right, so the downfall of the factor squares is that the factor squares stop at 100. So sometimes, unfortunately, you might have to do a little bit more work to figure out your greatest common factor than just looking at those factor squares and figuring out what matches. So if you're given larger numbers, we just have to do the factors of them. We have to figure it out. So let's review easy ways of factoring. If the number ends in 0, we always know that it can be divided by 10. 10 and 23. 10 can be divided into 2 and 5. Both of those are prime, so I'm done. 23 is prime, so I'm done. 136. I don't know factors of 136, but I do know it's even, and even numbers can always be divided by 2. Ava, take out your earbud, please. 2 and 68. 68's now on my factor squares, so I could go in there and figure out what it is, or I can just keep going with the whole 2 thing. It's even, so it's 2 and 34. And 34 is even, so that's 2 and 17. And 17's prime. So I can go this route and figure out what they share. I can now also say that the greatest common factor, they share a 2. Anything else?
No.
So the greatest common factor is 2. What if they shared a 2 and another set of 2's? What would their greatest common factor be? 4, because 2 times 2 is 4. What else do they share? They don't share any more coefficients. How many x's? X to the 4th. And how many y's? Y squared. And what did you say, Faith? My leading coefficient is negative, so it's not just 2, it's negative 2x to the 4th y squared.
Why would it be x to the 4th and y squared?
Because there's x, 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 x here.
Oh, okay.
And here there's 5 of them. So they share 4.
It's not letting me turn off my phone.
So basically just the lowest number.
The lowest exponent, yes.
Okay.
As long as there's both numbers.
Yes. So we're going to write our greatest common factor. And then we're going to divide. What's negative 230 divided by negative 2? 115. What's x to the fourth divided by x to the fourth? 0. It disappears, right? X to the fourth divided by x to the fourth is x to the 0, which is 1. We're done. Y to the fifth divided by y squared is y to the third. 136 divided by negative 2. Negative 68. If you look, that's 2 times 2 times 17. What's x to the fifth divided by x to the fourth? What? Just x. And y squared divided by y squared. Right? 2 minus 2 is 0. Y to the 0 is 1. It disappears. We undistributed it. Now again, here's why. Eventually, we are going to have a problem that says 6x squared minus 24x equals 10. And since there's an equal sign, we're expected to find the answer, correct? No. But this way we can't. However, if I factored it, can you now solve for x? And can you now solve for x? So you have to be able to take the problem and factor it so that we can then next solve for our answers.